So we want to look at our friend the array again and kind of take a look in an overview. And we want to look at how we can use this in some of our own ideas and thoughts. So if you will open up the textbook for this. So I have opened it up all the way to the end of the chapter. And at the end of the chapter, there's a lot of exercises, including the problem we're doing for a grade. There's another one I have an example for number 6 that you can look through. And I have some pieces. But what I want to look at is just number 1. And it just gives us an idea of what we might want to do. So design the logic for a program that allows a user to enter 10 numbers, then display them in the reverse order of the way they were entered. Okay. So that tells me when I first look at that, what am I going to need in this program? Could I build this program without using an array? So we could do it, and I'm going to open up a note tool here. So we could do this program, and we could have variable 1. We could have variable 2. And we could do that with 10 individual variables. And we could hard code it that way. So you would say input, and I'm going to shorten those just to make life a little easier for me. So let's just call that var1, var2. So we're just declaring those and saying those are going to be, in this case I think it says enter numbers, so you're going to say number var1. And good housekeeping says we're going to set it to 0 so we know that there's no junk in it. And so we could do this, and I'm just going to use our little So I'm going to go through here, and I've created this list of variables, and this is starting to get kind of ugly already. We have so let's see what we have. I can go back in here and change them. So I have 2, 3, 4, 5, 6, 7, 8. So we actually need 2 more still. So there's our 9. And then there's 10. So now we have 10 variables set up. Well, we could do this without anything else other than a straight sequence. We could input all of those variables in, and you could say input var1, and so we could then get the first variable, and so we could input all those variables in one at a time. Looks like I can't count to 10. So now we input them all, and we could certainly then print them or output them in reverse order, right? We could do that. So here we have another 10 statements. Output var 10, output var 9, output var 8. And so if I went all the way down through there, that would do what our program asks us to do. Because it would say, well, it allows the user to enter 10 numbers, then displays them in reverse order of how they were entered. So technically that works, doesn't it? But what if I wanted to increase that? Is there any easy way to increase this from 10 to 100? No. Would it work with 100 if I did it that way? Yeah, but it'd be pretty tedious. So the power we have is in a couple of pieces. One, we can loop things through iteratively, and so we don't have to do things like this. And now we have this idea of an array, so I can store those 10 numbers in a single array, and I can then iteratively call them back up. So let's rewrite this, thinking about this in terms of, well, now we can use an array. What can I do? So this program, or this instruction, said 10 times only. And if I hear the words 10 times only, the first thing that comes into my mind is using a for loop to input data. So we need to set up our variable. We know it needs to have the ability to have 10 things. So we're going to declare a numeric variable. So it's going to hold data. And so in this case, we'll just use our friend var, because we already are used to that. I put my bracket, and I say, all right, I know I'm going to hold 10 values. So I've now declared an array, and I could even house clean this, and I could put in 0, 0, and I could put in all 10 pieces, but we're going to leave it alone for now and just assume that our program's going to put in 10 pieces of data. So I declared a variable that's going to hold all of our data. But now I need a way to loop through and ask a user, hey, can you put in a number for me? And because we're going to force them to do 10 numbers, I could use our friend the for loop. So I could use any variable. And a lot of times in for loops we use I or we use X. So I'm just going to use I equals 0 to 9. So we're going to loop through from 0 to 9, which is 10 spots. And then inside that loop, we're going to say input var and put in that subscript of I. End for. So we're going to end our for loop right there. So all that loop does is counts 0 to 9, and each time it goes through there, we input a number. We don't have it very, very fancy. We're not asking a lot of things. We don't have any error validation. They could put in ABC, and we really wouldn't know if that were a good value or not. We need to output that values, though. And here's where it's really kind of handy. We know we have 10 numbers again. So I'm just going to use the same structure. So I'm going to use a for loop, and I can reuse my value I. So equals, now I'm going to say from 9 to 0, and I'm going to say -1 or step -1. So step -1. So I really should say up here, just so we remember that we're doing it, so step +1. So now it's going to do that count backwards, and it's going to count down from the top. So now all I have to do is put an output var end for. So this gives me a lot of flexibility. So one of the things I might want to do to make this even more flexible is I might want to make this so it's modular or able to change. And so one of the ways I could do that, instead of declaring this variable here, maybe I want to let the user input something. So I'm going to have the user input. So input, and I'm going to put quote marks here so you can, the quote marks mean that that's what's going to be displayed to the customers. So how many numbers are you going to enter? So now they're going to input so I put in their number of numbers. So up above this one, so I know that I have it declared, I'm going to declare a value, and I'm going to say num. We're doing a number. And the number of numbers, and I'm going to set it equal to 0. So now the user puts that in there and says, okay, I'm going to put in 50 numbers. All right. So now instead of putting this as a hard value, I'm going to put that as the number that we just got input. And in this case, I'm going to change that 9 to this. Do I need to make any changes, though, to that? So if you put in the number 10, how many am I actually going to go to when I count from 0? 11 or 9? So anytime we count, we always start counting at 1. The computer, though, says, I'm going to count to beginning at 0. So if they had put in this, and let's say they put in the number 15. Well, we declare our array with 15 elements, but we actually here have to go 0 to 14, or that number minus 1 is an easy way to do that. And then we can come down here and do the same thing. So it's just that weird little quirk of we start counting at 1. And so now this would work no matter how many numbers they put in there. So we could say they want 50, they want 100, they want 3,000. So instead of having to increase that size of that code, we've made it very scalable. It will change depending on our needs. So we could also have written this then, if we want to change it a little bit, we could have written it with a while loop, and we could have used something like a sentinel value of, please continue to keep entering numbers until you reach your last value, and then type ABC or 1, 2, 3 or some value we want. And we could have done it that way. But this shows two things. It shows how quick a loop is, and it shows off our friend that for loop, so it's an easy way to make a definitive number of loops. And it shows us how we put those numbers in our array. So if we looked in Excel and we looked at those numbers, so we put in 10 numbers, so we know we're going to have 10 buckets. We've just created, when we create that, we created a bucket over here at position 0, 1, 2, 3, etc. And then we put in our values. So 123, I keep it in the right line, and so on. And then when the computer reads us back to them, it's going to print them in reverse order. So it's going to take what we put in this way and reverse order it for us. So once we can handle a small piece like that, then we can move on to some bigger pieces. So it's looking at how do those arrays work, and then our friend the loop. And we put those two powerful things together, and now we can write some logic for some stuff. So the next one down, exercise 2, says design the logic for a program that allows a user to input 10 numbers, then displays each and its difference from the numeric average of the numbers. Okay. So we can probably use pieces of what we already have. And that's one of the great things about this class is once you get some of this done, you can keep reusing it. We don't have to reinvent the wheel every time. So we know that we can create a program that allows a user to put in 10 numbers. So let's look at that piece first. So I'm going to bring up Notepad. We're right through in. So we're going to get 10 users. So I'm going to take back out my piece here because we know it's just going to be 10. But I may actually just do this. Number of numbers equals 10. And that way, if I do want to change it, I can do that. So I've declared that, so we know that this is going to, in this piece, this first one is going to take 10 numbers in. We know that logic works. It says for I equals 0 to 10 minus 1, so 0 to 9. So it's going to put in 10 numbers, and it's going to put them in those index buckets of 0 through 9. So we know that part works. The next step then, it says, was displays each number and its difference from the numeric average of the numbers. Well, now we need to think a little differently. So we need to figure out a couple of things. I can do an output. We can do an output. And the output here, we were going to change this so it's plus 1. Bless you. And so I just use those to say, hey, we're not using that code, but I put it back in, and now it's going to take the numbers in and output the numbers. But it's asking me to output the number and its difference from the average. Well, how do I figure an average? If I have 3 test scores, how do I figure an average on that? Well, I look in Blackboard, but how does Blackboard create an average? Okay, so I'd add them all up and divide them by 3. Or, in this case, I'm going to add up all the numbers and divide them by 10. So how could I add up all the numbers? What could I do in here? I probably need another variable. So I'm going to declare one called average. I'm going to set it to 0 up here. So what I can think about doing then, in this loop, every time it brings in a number, so I'm going to input this variable here. So what if I said average is equal to average plus this variable we just put in? So it's kind of like an accumulator. Every time this loop runs, we take the existing value of average, and then we add in the new variable we put in there. So at that point, we really don't have an average yet, though, do we? We have an accumulated total. So maybe we really need to call that something different. So I'm going to add another variable. I'm just going to call that sub. So I'm going to declare one called sub, and I'm going to call it 0. And instead of average, because we don't know the average yet, I'm going to change that to just say sub equals sub plus 1. And so as this goes through, it adds up all my numbers. Now I need to figure out a way to find that average. And so I'm going to say average equals sub divided by, and I could just say 10, but if I just put in the value 10, again we have that magic number floating around in our code. And this way I can change that number. So if we wanted to input 10 numbers, we're fine. If we want to do 12, I can make one change in the code and it works. So now we have an average. But the program that I'm looking for says it wants to do something even different. It says displays each number and its difference from the numeric average of the number. So we're going to output not just the number, but it says we also want to do the difference. So we want output the number and we want minus average. And so there we get the difference between the two. And so now we can output one number. So if I did this, and let's just look at it really quickly, and I'm going to throw it in Excel because that way I don't have to count. So maybe these are let me put the rest of my buckets in. 6, 7, 8, 9. So there's all my buckets. So I'm just putting in a set of just semi-random, I hit a key numbers. So my program is going to ask you for these, and it goes through 0, 1, position 3, position 4, position 5, and it counts all those up. And if our logic is right, every time it goes through there, that sub is going to equal sub plus the variable we just did. So the first time through here, sub enters this loop at 0. So let's see what sub is going to be at every point in here. So sub in the first time is going to be 123. The next time it comes through, sub is going to equal 123 plus 456. Or now it's going to be 579. And so through the magic of Excel, I know that at the end of this string of numbers, when I add them up, sub is equal to 2,234. I'm then going to divide it by my number. So average then is going to be equal to, and it's that 2234 divided by number of numbers. In this case, it's 10. Our average is 223.4. So now when I output those numbers, so my output, so this is my list of outputs, it's going to output 123 minus 223. So it's going to be this value minus this one. Or the first one's going to say it's negative 100.4. And as I go through my list, that difference, you can start to see it, what those are. And I must have done something really wrong there, but that's so 579 minus, that should be right. Oh, I did it on the, I got it. Never mind. I did it on the sub number, not the actual number. So let me go back up here real quick. Let me do that. So that's D9. So D9, not D19. All right, so it's going to take the value that we calculated, and it's going to output this. So some values are ahead of that, some values are below it. So that gives us the difference from our average. And again, short program doesn't have a lot of pieces to it, but it's expandable. So if I wanted to do this to 5 numbers, I really am only making one change, and the same program works. So it's scalable. It can scale up, it can scale down, either way. So it's a quick, easy way that we can do that. So these arrays are a handy, handy way we can store data. And even better, if we can store data and we can put it in parallel. Because when we put data in parallel, then we can search through one record and reference another record. And so if I look at number 3, it says the city of Cary is holding a special census. The census takers collect one record for each resident. The record contains a resident's age, gender, marital status, and voting district. The voting district field contains a number from 1 through 22. Design a program that accepts data for each resident until all have been entered and then produces a list of all 22 districts and the number of residents in each. So, we have to kind of think about this one. This one's a little more complicated. We need to break it down and see what kind of items we're going to need. So, I like to use Excel, especially when we're working with arrays, because I can use it and kind of figure out what data I need and what variables I need. So I'm going to delete all this junk here. And so I'm going to put up here that this is Cary, just so I know what I'm looking at. And I want to pull out the essential pieces. So it says I need a record for each resident. And that numbers are going to contain, so we're going to have age, we're going to have gender, marital status, what else are they going to have? And voting district. So we look at this and like, okay, so we need to have some way that we can collect all of this data. One record for each resident. The record contains a student age, blah, 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 blah. All right, so where might we start on this? What could we do to start? But we have some information, and we know that the voting district field contains a number from 1 through 22. So in this one, the district, we know that there are 22 districts. Do I have any idea of any other information in here? Does it give me any clues? How big is the city of Cary? So somehow we need to make this modular enough that, because we don't know. This is all the information we got. And we need to figure out how we can input data. So it doesn't say, and so we can make some wild assumptions in here. It doesn't say that you're going door to door and it could be in any kind of weird order, but it does say that we have 22 districts. So if I'm going to do numeric order data, maybe I could do them in order of those districts, and I could save myself a little bit of time and trouble. So in other words, I make it for one district and I loop through that. So I'm going to get rid of all of this stuff here. All gone. And so maybe I make a value for district. And I'm going to set it to 0. And I may also declare one for and just because I know it's a constant, I may capitalize it. And I know that that's 22. I could make a loop So I could make a loop, and in there, if all I had was one resident, so I could enter in that information very easily. And so, indulge me here just a second. So I'm going to output enter data for district number, and then I output that value of I. You see that? So every time this loop, it's going to put enter the data for district number whatever. So inside of there then, I could input data for that district. And so I could input age, I don't remember all our things we're going to do, input gender, input MS, marital status. We know the district, so we're getting some values in there. So I could do this 22 times, but I'm not sure that we know how many people are in each district. And so we may need to think a little harder on this one and figure out a way to come around that. So this would sort of work. But does that age, gender, and the marital status, is that going to work? We haven't defined an array for those, so we may have to think a little bit harder on that. So maybe what we need to do is think about an array and what might be in those arrays. So we don't know how many people there are. We'll have to figure out a way to get that so we define the size of that array. But that array could contain these items here. So what it doesn't ask, weirdly, is a name or any way we can identify them. So we'll have to come up with that. So if I looked at Cary and I said, all right, we know that there's only 1,000 people in Cary. So maybe we define a new one up here. So we say number, and we're going to call this population. And we're going to set that equal to 1,000. So then we could define some arrays based on age, gender. So we want to define an array for age. So we would declare a numeric array for age. And we're going to base it on our population. So we can make this scalable. So now whatever we put in there for population, we get one for an age array of 1,000 elements. And we can do an array for gender the same way. And we could do one for, in this case, we're going to call it M_S because I'm too lazy to type it out. Population. Now, we declared a district, and we said district from 0 to 22, because we know there are only 22 districts. But we want to create a record, maybe, of each one of those. So maybe we're going to do it a little differently. So let's declare another variable. And we already used the word district. So just to make our life easier, we're going to just call this one DIST. So we know that there are only 22 districts. But in here, we're going to go through, and so we're going to still do this way. We're going to just do a data count. So somebody has pre-sorted all this values for us into piles for each one of these districts. And so somebody will input all the data for District 1. Somebody will enter all the district for data 2, for 3, for 4. So I is equal to the 0 to the number of districts minus 1. Because remember, we've got to count a little weird. So we can either do it this way, because if we didn't have that in there, it's going to try to go through this not 22 times, but 23. Because it's going to count 0 to 22. But because we want to use that number in here, I'm going to actually say 1 to the districts, step plus 1. So we're still going to cycle through there. And we're going to have them input their age. So age. Now, what we don't know in this particular case is we don't know what this value is yet. So we have an array, and we're looping through each particular array, but we don't know how many people are in each district. So we're going to have another loop inside of here. Some way we can keep count. Does that make sense? So we have to be able to, we have 1,000 possibilities in here for this array for age. So we have several different ways we can do it. So maybe I get rid of this completely, and I just say I equals 1 to population. So this is the easiest way you could do this. So 1 to population. So we're just going to count through all 1,000 people. And so age becomes input age at I. Input gender at position I. Input MS at division I. And then we just add an input for district, and we input I there. End 4. So this would loop through all of the data you're going to have. So you would go through 1,000 different times to go through there. So that would, in theory, work. And you would end up with, so everybody that comes in here, let's think about this. So the first person that comes in, so we're in position 0, and they're going to put their age as 23, their gender is male, their marital status is single, and their district is 1. And they're going to go through and put in that data 1,000 times. And that actually would work. We could get all of that data for that entire groups of people. Now we have 1,000 buckets here filled with data. And we're not going to go through, normally I would go through a whole piece about how we validate this data. But let's just say that everybody behaves and they enter only ages where it's appropriate. They enter male or female for gender. They enter single or married or divorced or whatever our criteria is for marital status. And nobody puts in the wrong district. So we have another male. This one happens to be married, and he's in District 4. So now we have all this data. So there's 1,000 items of data over here. So it got the data. It's kind of ugly. It's not very pretty, but it did it. what can we do with that data in there? Can I use those parallel arrays to find data? Is there any way I could search through there and find all the people aged 12 and what their genders were? Yeah, we can loop through it. And if I can find something that matches this, then I know that they're in District 1 because I can use that subscript that I found. So I can match those up. And so if I had a name, so if we expanded this, I could then even match it to a name. And I had an address. So these parallel arrays are starting to set that foundation for how we can store a lot of data. Really, really useful data. So we have this particular problem. So there's a lot of different ways you could do that. So for the revision piece of that, it says design a program. Not only does it take that data, but produces a count of the residents in the following age groups. So under 18, 18 through 30, 31 through 45, 46 through 64, and 65 and older. And so we can use those arrays to count or to group people into those questions also. So there's a lot of different ways we can do that one. And then if you look at, go back here. So if you look in your assignment, open up number 6, open somewhere. So I put in a Word document, I put number 6, including a PowerPoint or a flow chart for it. So let me go back to the problem, which is in so let me open this up. We can take a look at number 6. So 6 says, the Billy Goat fast food restaurant sells the products shown in the table below. Design the logic for an application that reads in the name of an item ordered by a customer and outputs either the correct price or the message, sorry, we don't have that item. So we look at our table, we only have 3 products. So a cheeseburger, a Pepsi, and chips. We're a small scale operation. And it gives us a price. And so we're going to have to allow a customer to input a value. So when I look at one possible way we can do this, enable editing. So let's see if I can make this a little bigger. So what we're doing here, and sometimes it's easier to think about these problems in a flow chart, is we're going to know we're going to take an item in. We say, yes, you're going to input an order. Great. In this case, we wrote it so it just says, are they done ordering? So we have a very simple way that they escape out. Maybe the logic is they write, 999 or whatever the question is. And so we ask that question about, do we have that item? Well, if we look up here, we said we have size is equal to 3. That's the number of items we have in our menu. So we've said size is equal to 3. And so our question actually asks, as we go through this loop, because we're going to loop through every item, so we're going to compare what the user entered and what's in our existing data structure, and we're going to compare the two. And we do that here by asking, is X less than size? And X is a number we declared right here. And we declared that, so that's our counter through there. And so as long as X is less than than our size, so in other words, it's less than 3, we're going to come through and we're going to say, does your item ordered, so what you put in, so when you typed in hot dog, does it equal product of subscript 0? And subscript 0, when I look up here, because we just hard-coded those right in there, subscript 0 is cheeseburger. And so we compare the two. That isn't a result that's going to get us anywhere. So we say x equals x plus 1. In other words, we increment that counter. And we come back to our loop again. Well, so now x is 1. So 1 is less than 3. So it loops again. And so now it's going to say is hot dog equal to position 1, which is Pepsi. No. So it's going to add 1 to it again and come back up here. So now x is 2. 2 is still less than 3. We ask again. So is a hot dog equal to product at position 2? Position 2 is the third item in our array, or chips. No. And it comes back up here to the top of that loop and says now 3 is less than 3. And that's false. And it jumps out of there and it says, well, did you find it? Because we used another variable, just some kind of a signal. Did we find the item? And so in this case it says nope. And it says output error message, because found it is still 0. It didn't get changed because we had found the item. And then in this case it says, oh, now we're going to input an item again. And it starts our loop all over again. So users can input unlimited numbers of items until they enter a Sentinel value, something like 999, whatever we've set that at. So let's see if they ordered a cheeseburger, what the difference would be. So they type in cheeseburger. We come up to the top of this loop. So found is still equals 0. X is equals 0. 0 is less than 3, so that comes over here. And we say, does cheeseburger equal the item at product under or index 0? And that's cheeseburger. So we're saying, does cheeseburger equal cheeseburger? Yes, that's true. So then it says, here's your price. It says x is equal to size. So x equals to size does something interesting. And so we'll take a look why that's going to interest me. And then it also says found equals 1. So it flips two variables, changes them. So it comes to this loop and comes up here. Well, now x is equal to size, so it's going to say 3 is less than 3. And we know that's false, and it comes out. Found is equal to 0? No. And so it allows you to order your next item. It doesn't give you that error message. But this piece here, saying x is equal to size, that escapes us out of that loop as soon as we find an item. So that's an escape clause out. So in 3 items, it's not that bad if we had to go through those. But if we had a normal restaurant menu, this would be a great way to dump out as quickly as possible. So imagine your McDonald's. You went in there and they only had 3 items. They're probably not going to be very profitable. So what we need to do is we made this scalable by doing these. So now, even if we have 1,000 items, as soon as we make our match, it's going to leave this loop. So we don't do it repetitively. So if we look at the pseudocode for it, so the actual code, this loop, so while not end of file. And so when we actually code in Python, you're going to have to create what constitutes end of file, or the end of your loop. But for now, we're just saying end of file. So we've got some structure that allows us out. So here we say our found is equal to 0, x is equal to 0, and we start our loop. And so that same loop that we looked at in the flowchart is right here. So while x is less than size, and then this we know, this blocked in area then, is all things that occur in that loop. So we use those indents to block that in. So if item ordered equals product at value X, now we're sorting through our array, then output the price. If it's equal, then we output the price. We also say X is equal to size, and our found is equal to 1. Otherwise, X equals X plus 1. So in other words, we add a value to that sentinel value so we can continue our loop. So we get through this loop in whatever condition, and then we have this if statement here. So we say if found equals 0, then output the error message. So in other words, we don't have a loop, we just have a selection. And if we output the error message, then we come out to the top of that loop again. If we have an end if statement, where this then runs either way. So in this case, only if founded is equal to 0 do we get an error message. In both cases, we come back up to input item ordered. And so when I look at my code up here, this input item ordered is part of this loop here, that loop of end of file. So notice I have to have a priming input up here, and then I have an input item in the loop itself. So this is a while loop. So while not end of file, I don't know how many times it's going to go through. It may sit on the screen the entire day. So maybe this application, all it really does is allows us to check prices, and so somebody can write them down. So if you've been at McDonald's, McDonald's now has pictures on their menu or on the cash registers. And so maybe you have somebody up there and all they're doing is pushing cheeseburger, Pepsi, or chips. And then we can get the prices, and then we can add in the other piece. Because right now all it does is say here's a price. It doesn't give us a total, but we could modify this to do that. And so this structure that we look at here, you're going to see over and over again. So make sure you've looked through it and you can kind of do that desk audit and work your way through those. So there's a lot of material this week in the class. No, this one. So on top of the lecture from today and looking in class, there's sample problems, there is lectures from last year, and there's even one that's just working on the homework itself. And I don't think it'll play over the video recording, but looking at just the homework. So this homework ramps up a little bit in complexity. This is so far our most complex piece we're going to do. But it's still broken down. We have 3 small pieces. So part of the way we can work on this is by not getting overwhelmed. So when I start Notepad, I don't start with all of this. I start with the idea of, all right, I have a start and I have a stop. And then I start building it in small pieces through here. So I look at how do I start breaking down these small pieces. And so we end up with our question is for this week. So you're doing part 5, I think it is. Yes, sorry. So 5 says, Watson Elementary School has 30 classrooms numbered 1 through 30. Each classroom can contain any number of students up to 35 students. Each student takes an achievement test at the beginning of the school year and receives a score from 0 to 100. Write a program that accepts data for each student in the school, student ID, classroom number, and a score on the achievement test. And then design a program that lists the total points scored for each of the 30 classrooms. So not each individual student. What we're looking for in this case is we're looking for the total points scored for the classrooms. So this one's going to take a little thinking and setup to get there. So you're going to have to first think about how I'm going to structure it. How am I going to take in that data? How much data am I going to have? There are probably 1,000 different ways we can configure this. So that's one of the challenges in here, is there's not one right answer. There can be multiple ways to do things. So there also is the opportunity to earn some extra credit. And so extra credit would be adding in Part B. And so Part B, if you submit that, you say, well, now we're going to modify this so that we can get each classroom's average of the test scores is displayed rather than each classroom's total. So somehow we have to get from, we know we have a school with 30 classrooms, and we know that each classroom can have up to 35 students. They don't have to have 35 students, but they can have up to 30 students. So this one's going to take a little more processing and some more time to complete than some of our other ones. Because at most, you would have a data set of a little over 1,000 data points, but you might not have that many. So there are literally hundreds and hundreds of ways to do it. So make sure you look at not the right week 4. Make sure you look at these samples. Make sure you look at lecture videos. Make sure you've looked at the book and you kind of have that idea. And writing them. There's no other way to do this other than trying to write this code over and over again until you say, all right, I think I have a way that this will work. Because if I were just doing a simple one classroom, we could do it very similar to what we just did with the fast food restaurant. So you create a while not into file. So in fact, we could take that code that we just had, and you could say, all right, I'm going to modify this piece of code. And you'd have to change your variables, but while not into file, and then you could come in here and you could say, all right, I'm going to input these pieces of data. And so you have to figure out what variables you're going to use. So while not found in each classroom. So you could do that. That might be a hint. So as you loop through a classroom, so you are going to have, or probably the best way to do this in a modular scalable method would be to use a nested loop. So you have a loop inside of a loop. Well, they're not scary. We had one here. So if you look at this, we've got a loop inside of a loop here. So they're not horrible and scary. This is a loop within a loop. So here we have a loop, and this loop happens to fall inside of this one. So if I design kind of from that inside out, I think it's easier. So if I can figure out how to get all the data for one classroom, then I loop that module however many number of times of classrooms we have to get that data.